So, there we go with our third video. Time is passing fast, and a careful planning of the work is necessary to end everything on time and recover fast from glitches. We identified some milestones which point out the main achievements of our work. Performing the state-of-the-art analysis was not an easy task in our case, given the generality of our problem. Choosing among the algorithms was even harder, because we had to guess the one that best suited our needs. At this point, two threads of activity split, with respect to the technical side and marketability. From the technical standpoint, an early C implementation is the first milestone. It is essential because the HLS process, the preprocessing stage performed on the host, and benchmarking activity will be based on that. From then on, it will be possible to start the implementation of the backend of our hybrid approach. This is going to sit entirely on the FPGA. Iteratively, we will perform validation, benchmarking and optimization. The end of this design space exploration marks also the end of the technical part. On the opposite side, there is the whole market analysis. The entire process has to be completed by the submission deadline. The state-of-the-art analysis kept us busy up to the end of April. From then on, it is possible to start the real implementation, which takes place on a general-purpose machine first, and then slowly ported to our target platform. The final stage of the implementation amounts to the communication infrastructure between the host and the FPGA. We will write the report alongside the development. A great deal of our documentation will be covered by our state-of-the-art analysis and market analysis. Hopefully it will be finished soon, so that we will be able to focus on the last tweaks to apply to our project. Beware the deadlines. A wise man once said, "If you have to fail, do it as soon as possible." This is because you can adjust your site without wasting too much work. We already pivoted since the initial approach proved to be unfeasible for the datasets we wanted to process. We adopted the KISS paradigm since we wanted to avoid overcomplicating things, and we stuck to FPGA-friendly data structures. We identified a new hybrid approach which delegates only highly parallelizable tasks to the FPGA. We still have to choose between Algorasic and Vumamber algorithms. Our SWOT analysis also takes into account these alternatives. Our main limitation at the moment is the scarce experience in the hardware design field. We hope that this project will allow us to grasp at least the basic stuff about HLS and FPGAs. Market analysis is another critical point. Our problem is way too general to easily identify a final product, since algorithms are open and in the state of the art. However, the need for string matching in many contexts would allow us to overcome the limits of a niche market like the one of genomics and export our solution in other fields. The Algorasic algorithms has already been implemented for proteins pattern matching. An implementation for the DNA would be relatively new, even if not revolutionary, but would be guaranteed to work well. On the other hand, performance of the Algorasic are already outstanding on GPUs. We will have to compete with them at a certain point. We may either choose a favorable metric or switch to Vumamber. This is risky because there are no previous implementations in hardware, but the profit in case of success would be high. The fact that we pivoted is a pro, in the sense that it shows our capability to recover from errors. Stay tuned, interesting stuff is coming in the way, and in the next video we will also introduce ourselves.